Hello, this is Bryson, and welcome to my Python tutorial series. This is the first video in the series, and in this video I will be talking about the basic computing concepts. The basic computing concepts I'm going to talk about today are variables, control flow, and input and output. So let's get started. So the first major concept in computing is that you store information, right? Because if you can't store information, you can't really do much with your code, because you will always be forgetting the things that you do. So that's why it's a good idea to store information. And the most basic way to store information in programming is through variables. And the variables in computer science are a bit different than math variables. In math, variables are usually used to represent unknown values, but computer science, variables are more like a box, and then that you assign a name and it stores a value inside. There are some variable types like integers, decimals, booleans, strings, and objects. And in some languages, you will have to specify the variable type while you initialize your variable. But in Python, you don't have to. And this is a Python tutorial series, so I'm going to be showing my examples in Python. And variables can be constant or mutable. So you can make variables never changing. So if you set a variable to 1, you can't change it to 2 later on. And sometimes you just can have variables that do change. So you can set 1 to 2 later on. So in this example, you see that name is equal to Johnny and age is 21. So now name is the name you gave your box, and now Johnny's inside the box. Well, the name Johnny, actually, human's not inside a box. That would be pretty bad. And then now you have a box with age label on it, and 21 is now inside the box. So name now holds Johnny, and age now holds 21. So another concept that you need to know is control flow. So sometimes you want your code to run in different orders or something, or only during certain conditions. So while talking about control flow, you have to know about conditional statements. And conditional statements are statements that result in a Boolean. And if you don't know, a Boolean can hold 2 values. It's either true or false. So Booleans are. And okay, so conditional statements compare 2 things. And the basic ways to compare are equals equals, which is are they equal to each other? And not equals, so exclamation mark usually represents not. And you should probably recognize this. This is greater than, this is less than, this is greater than, and then equal to, and this is less than or equal to. You might be wondering why there's 2 equal signs here, and that's because, as you remember from a few seconds ago, single equals is just for variables. So that's why you need a double equals in order to specify that you're comparing 2 things. And you can combine multiple comparisons with not and or. So not is the exclamation mark, and that's just flips the value. So if it's true, then you go not true. So not true is false, and then not false is true. So it just flips whatever it is. And then it just means that if you have 2 statements and in between them, both of the statements have to be true in order for the whole thing to result in true. If either one of them is false, the whole thing is false. And in or, either one can be true and the statement will result in true. Both of them have to be false in order for the statement to result in false. So yeah, conditional statements result in Booleans. So let's look at this example. So you see that age is equal to 21. So that's the single equal sign because you're putting 21 in age. And now you have a variable which is going to store a Boolean. So is discounted equals age less than 18 or age greater than equal to 65. So you see here we used or. So or is gonna, if either one of these is true, then is discounted is going to be true. But if we look, is age less than 18? No, because 21 is greater than 18. Is age greater than or equal to 65? No, because 21 is not greater than or equal to 65. So that means since both of them are false, is this count is now going to hold false. So with knowledge of conditional statements, you should be able to understand if-else statements. So if-else statements are powerful because they allow code to only run at certain circumstances. So if-else statements in Python, you create like a block of code, and then that it only runs when a condition is true, and then the condition that you give is a conditional statement. So it's also Boolean, or you could just put a Boolean. So like, and then the type of statements there are if statements, else statements, and else if statements. So in this example, green is going to hold a Boolean. So if the green variable has true in it, you're going to go, oh yeah. Also, yeah, by the way, hashtags in Python denote comments. So whatever you put in a hashtag, after a hashtag, it's not going to be read by Python interpreter, which is basically where you like write your Python code and stuff. So now we have a if and then an else statement. So if green is true, you're going to go, and then you skip this else statement. But if green is false, you go to this else statement, and then execute whatever is in this else statement. And then here you have if green, so if green is true, you're going to stop here. But if green is not true, you're going to go to this else if statement. And then else if in Python is elif. Yeah. And then if green is false and yellow is true, you stop here. But if green is false and yellow is false, then you finally go to this else statement, and then you stop. So that's basically it for if-else statements. And then now there's loops. So loops repeat code until something is true or something has ran out of values. So the first type of loop is while loops. And while loops execute a block of code as long as the condition is true. And they are usually used with a counter. So we have here, while green is true, you're going to go. So if green ever becomes false, then this is going to stop working. And then this is a while loop used with a counter. So you have your counter in this case is I. So I is equal to 0. And then while I is less than 20, I'm going to print I. And then you're going to increase I by 1. So let's like go through this. So like a while statement is actually kind of like an if statement because like it also has like conditional statement. So like if I is I is equal to 0. So is I less than 20? Yes, it is. So you're going to print I. So you're going to print 0. And then now I becomes 1 greater. So now I is 1. I is still less than 20. So then you're going to print 1. And then you're going to increase I by 1. So it becomes 2. And on and on and on. So this is actually going to print all the values from 0 to 19. And that's like not that much code. So that's why loops are pretty powerful. The next type of loops are for loops. So for loops are usually used with iterable objects, which just means there's like a set of things that you can go through. So like it's like a list, and then you could go through each element in the list. Sets in Python aren't iterable because they're not stored in order. So like the conditions for iterable is that you need to have like multiple things inside a box, and they need to be ordered. So there's a specific way to loop through them. For loops are also usually used with range. And then this range function actually returns an iterable object. So if you look in the example, so for I and fruits, print I. So like fruits, there's probably going to be like oranges, like banana or something in there. And then for each element in there, it's going to print it out. So like if there's oranges and bananas, it's going to print oranges and bananas. And then if you look here, so for I in range 20, so range 20, what the range function does is that it returns, if you only give range one number, it's going to return numbers from 0, all the numbers from 0, including 0, that are less than the number you give. So range 20 is going to give all the numbers from 0 to 19 inclusive. So this is going to print 0 to 19. Exactly the same thing this is going to print out. But as you can see, this for loops looks much better. So if you're going to do some like simple like looping, you might as well just use for loops. Then this is how you break out a loop. So like sometimes you don't want to have a loop run until completion. Sometimes you want to break out earlier. Well, if you have the break keyword, then it stops the entire loop and moves on to the part outside of the loop. And then if you use the continue keyword, it stops with the current cycle and then moves on to the next cycle. So now we go on to input and output, because if you can't input and output things to a program, your program's basically useless. So output, so you basically give a value outside, and the most basic form of a output is the print statement. So you got like print hello world, that's like a classic, but I'm gonna put print X here because we've got to be different, you know. So you can also output to a file, and that's much more complicated, and you're probably looking at this like confused, but you probably don't need to know this until later, and I'll go into this more in detail in a later video. So once you know output, you also need to know input. So you receive a value with input, and the most basic form of input is input. Wow, that's so intuitive, right? So you could pass a string to input to be the prompt, and you could also read from a file just like you can output to a file. So X is equal to input and then print X. So whatever you, once we do the example, you'll probably see how this works. And then this is also pretty complicated, and I'll go over this more in detail in a later video. But yeah, so that's basically all that we need to know in order to create our rock, paper, scissors game in Python. And you might not understand all of what I said like just now, but hopefully once I go through the rock, paper, scissors game, things will start to make more sense, and then you'll have a better grasp of how the syntax works. Okay, time to get on with creating our rock, paper, scissors game. So I defined an objective, which is to create a rock, paper, scissors game that can run multiple times. So the first thing we are going to do is actually something I didn't mention before in the video. But since we don't want to play the same rock, paper, scissors game over and over again, we need to introduce a bit of randomness. And in order to introduce randomness, we need to import a library called random. And then in order to import a library, you use the import keyword and then the library name, which is in this case random. And then what this does is that it makes your program able to use any of the functions that are in this random library. So that's what that statement does, and it's actually not that confusing. And it's also a good practice to put your import statements at the top. And it's also good practice to not import everything. As you can see, REPL is complaining that I imported random, but it's not used. But I will use it later, so I could ignore that right now. So we're also going to have a user response. And then we're going to initialize this to empty string. The reason we're going to do this is because we want to have a thing. So like when the user inputs Q or something, we're going to break out of a while loop. But in order for the while loop to know what the user actually, in order for the while loop to run the first time, we need to initialize user response. So now we can make our while loop, and then so while user response is not equal to Q, we're going to do something. So if I didn't do this, let's see what would happen. I'll put like print hello world, classic example. So if this was not here, you will see that an error pops up because user response was not defined. That's why we need to define it first. And I'm going to get rid of that. So now we kind of want to give some instructions of how our game works. So we're going to print some instructions, and then in this game we're going to define 0 to be rock. So 0 is rock. And then 1 is paper. And 2 is scissors. Why this? Well, it's just a definition, and a 0 kind of looks like a rock, A 1 is kind of like a paper, and 2 is kind of like a scissors. Yeah. So now we're gonna take the user response again. So we're gonna have user response is equal to input of. And now we could give a prompt like I mentioned in the video, but I didn't really talk in that much detail. So I'm just gonna put like enter your choice. Enter choice. Yeah, and then so now we got our user response. And now the CPU is also gonna make a response, right? So and then we want it to be an integer. So we could go like CPU response is gonna be, so this is where the random library comes into play. So random.rand int. And as you can see, when I do this, you could look at what rand int does. So it turns a random integer in range a to b, including both endpoints. And since we only have the options of 0 to 2, we're going to put 0 and 2 here. So rand int is a function in the random library. So you put the library name and then the function that you want to use, and then pass these are parameters. So you pass your parameters in. So now we're going to do like if. So now we kind of want to filter some of the responses that we get. So like if someone puts 3, we should not do things with it. We should tell the user to read the directions carefully. So if user response is not in 0, 1, or 2, we should also account that if the user response is actually equal to Q, so user response is equal to Q, then we're gonna break, because if they put Q, that means they quit. So I should probably put here too that Q is quit. And so once you break, the reason I'm not gonna put an else here is because if there's a break, it also automatically doesn't run what's after it. So I'm gonna put read directions carefully here. And then, so that's basically what our filter is, all the filtering that we need. Then now we could put an else statement, and our else is gonna be that they did enter either 0, 1, or 2. So we're gonna convert the user response to integer, and this is using a concept called casting. And it sounds kind of weird, but it's actually not that bad, and I will probably go over this in a later video too in more detail. But all you need to know is that if you put like int and then like a thing in there, it turns into an integer. So go int of user response. So now user response is the int of what user response was. So now user response is an integer. And now we could do some comparisons. So let's think what a tie scenario would look like. A tie scenario would look like if the CPU response is equal to the user response. So then let's first check if there's a tie. So if user response is equal to CPU response, then we're gonna print it is a tie, or it was a tie, or, you know, I kind of forgot grammar, so I'm just gonna put it is a tie. And then else if, because I'm gonna use elif, because if something is a tie, you don't want to check if it's a win or a loss, because you already know it's a tie, and a tie can't be a win or a loss. So that's why you do else. And why you have if after that to make it elif is because you're still going to check for additional things to be true. So let's see, CPU response. So let's see, if I chose scissors, the thing that beats me is rock. So that's directly 2 below. If I chose paper, and the thing that beats me is scissors, so that's exactly 1 above. If I chose rock, the thing that beats me is paper, which is exactly 1 above. So if CPU response is equal to user response plus 1, so that's like, that covers like 1 beating 0 and 2 beating 1. But what about 0 beating 2? So we gotta put an OR here. So OR CPU response is equal to user response minus 2. That means the computer beat you. And that's kind of sad. So we're gonna put print you lost. And to emphasize the sadness, we're gonna put a sad face. And if you didn't tie and you didn't lose, you should have win. So we're gonna print, so we're gonna put that in the else statement. So you're gonna print you win. And to emphasize your happiness of beating a computer, we're gonna put a smiley face. So that's actually basically it for the main portion of the code. But let's print something as a farewell message. It's like, thank you for playing. And yeah, that's basically the bulk of the code. But I'm also gonna add in a counter of how many wins, ties, and losses you have. So here I'm gonna put ties equals 0, that's 0, wins equals 0, and losses is equal to 0. So after printing thank you for playing, I'm gonna print the statistics. So print you have, and then this is also some string formatting here that you don't need it. I'll go over in a future video. Let's see, I'm gonna go wins first. So wins. Wins. And then gonna copy and paste. Copy and paste is gonna be your best friend while coding because a lot of code is repetitive. So this is the losses goes here, and ties go here. And then we also need to increase these counters, or else it's always gonna display 0. So if you win, wins is gonna increase by 1. You should recognize this from that while slide that I put up. If you lost, losses should increase by 1. And then if you tied, ties should increase by 1. So let's run and have some fun. Hey, that rhymed. Okay, so what is your choice? I know that you're thinking rock. Oh, sad that you lost. But I know you're determined with picking rock, so I'm gonna put rock again, and wow, you won, and you even got a smiley face. Well, now I'm gonna choose scissors. Oh, and I also win. Ask your friend. He probably picked paper, and they also won. And let's just keep spamming rock because rock is seemingly the strongest, because you could actually beat paper with rock. You just need to throw your rock hard enough. So that seems like a good amount of times. And then theoretically, if this was all working, we should get a close to even amount of wins, losses, and ties. So now let's press Q to quit. And wow, we actually performed okay. We don't have as much ties, but that's probably just due to random chance. The more we do this, the more wins, losses, and ties are probably going to equal out. But we did win more times than we lost, so I call that a win. And based off this happy note, I'm also going to end this video. And even though it's a sad time, there's always going to be more videos in the future just like this. So be sure to subscribe and like this video, and leave a comment. Probably refresh the video to get some more views on this video. So yeah, that's it for now, and see you next time.